covering more and about the basic about the in my is it clear now? Is it clear now? Can you hear me, sir?
Your audio is very low, sir.
Sometimes disturbing.
Just a moment, sir. Just a moment, sir. I am checking 1 second. Yeah, I kept 100% here. Let me check the mic. Yeah, is it audible now? I'm a bit louder. I'm speaking a little bit louder now. Can you hear me?
Yes, it is clearly audible. Clearly audible.
Okay. So I'll continue on the presentation and about the product. Here we would be covering these are all the topics. One is introduction about Hvac system, like what is Hvac and what are how the system functions, what are all the components, so that if many people will be aware about the air conditioning system. Still on railway, what is the additional features available in the design aspect, so that for maintenance it will be easy. Second is performance of the Hvac system. We'll be covering about this topic. And maintenance basically the very important for any good operation or reliable product running in railways. So we'll be covering points related to maintenance. And basically the reliability backbone is maintenance. If maintenance is done well in time, so that the reliability of the product will increase and downtime will come down. So and finally I'll be touching for 5-10 minutes about the cab air conditioning unit. The driver cabin AC also most important, like our pilot have to have a comfort, so that little bit cover on the driver cabin air conditioning unit. So wherever is any doubt, please feel free to stop, or we can have a question and answer session at the end of this program. Yeah. So here basically why ventilation and air conditioning unit. Basically what it is, heating, ventilation and air conditioning. Normally in our domestic home and all, we will having only air conditioning system. Okay, yes, in north part there are northern India, there are heating and cooling, both mode of air conditioner is available. Whereas our train travels from all the locations, different environment conditions, I could say. So why actually heating, ventilation and air conditioning is required? Basically to give the comfort to the human whoever traveling in the train, to keep the temperature and humidity. The temperature and humidity, why it is important? Basically our body will work or give a comfort if the temperature surrounding the body is normal. If the temperature is too high also, we face the difficulty in discomfortness, and as well as the humidity. In coastal areas, people sweat a lot, so and gives a discomfort to the human, whereas air conditioning, it will maintain the temperature as well as the humidity. So what will happen into the system? The air conditioning process is basically cooling, dehumidification. Dehumidification basically to maintain the percentage of relative humidity in the conditioned space. That is how the compressor will run, and we will be going to cover more in detail in the coming up slides. And okay, so far we have covered two things. One is the comfort, human comfort, one is important, and equally the air quality is also most important for the human. So in heating, ventilation and air conditioning unit, there are air filtrations are available. So whatever the air which recirculates, as well as the certain amount of fresh air which is taken from outside, there are pre-filters, that is a fresh air filter, as well as the return air filter to remove the dust particles and then give the certain amount of quality air to give the comfortness. So by regarding air filtration and indoor air quality, we'll be going to cover more in detail. Particularly in this project, the HVAC is having additional feature, so that we will be discussing more on this topic. So we discussed about why heating, ventilation, and air conditioning is required to give comfortness as well as the quality of the air. So now we get into how the system functions. What is the basic of the system? To achieve the desired condition, there is a mechanical process happening inside the system, that is compressor. To create the required temperature pull down, there is a process, vapor compression system, and then there is a condensation and evaporation. So this is how the cooling is created inside the compartment. So in next few slides, I'm going to show the schematic of the basic air conditioning system, so that that will give a clarity. So here, this is the basic system. You can see at the center middle, this is the compressor, whereas the compressor which compress the gas, that is the refrigerant, from low pressure to high pressure. So whenever any gas which is compressed, it will generate heat. So to remove that heat, there is a condensation process. Here, this is the heat exchanger. In this, we are using a fin tubed air-cooled heat exchanger. The heat is removed here. Then at the outlet, it will go as a semi-liquid. It passes to the expansion device. And in expansion device, there will be a sudden expansion. Due to that, the action in the temperature. So takes the heat, that is the cooling, and goes outside. So similarly, this cycle will be keep on going. One is the refrigeration cycle, and the other one is condensation and evaporator section, where the blower will be keep on recirculating the air to keep the temperature and humidity to the required design condition. Okay, so when we talk about what is the capacity of the unit we are going to give for this project. This is somewhere around 8 TR, that is approximately 29.15 kilowatt at 50-degree ambient. Normally in Indian Railway, whatever products we are giving, that is a very rugged design. At any extreme condition, the system will give the desired cooling capacity to maintain the temperature and humidity. This system is designed for 50-degree and 13% RH, that is 25% wet bulb temperature, and approximately 10 kilowatt, less than 10 kilowatt heaters are available that will work whenever the temperature goes below 18-degree. And the unit dimension we have given, that is 2.5 by 2.1 by 0.5 meters without mounting. And these are all the air volume which the unit will deliver at this much static. And the refrigerant what we are using is R407C. So for maintenance perspective, the refrigerant what we are using is R407C. To tell a brief about this refrigerant, this is basically having a blend of 3 gas. So handling or anytime charging or removing, there are good practices mentioned. We have to follow that so that the system will not have any problem in operation. Okay, coming to what are the major parties here. Compressor. This is the heart of the system, which create the cooling in the air conditioning machine. And we are giving variable speed triple VF compressor here. Why triple VF compressor? See, triple BF compressor has been used almost three decades before in normal domestic and commercial air conditioners, whereas now we started using in variable speed in railway application. See why it is so late? Since railway compressor or any components we are using, it should withstand all the vibration as well as the worst environmental condition. The compressor has been developed recently, so we started using this now. And what is the benefit of variable speed compressor? Here, to modulate the cooling capacity. See that, like based on the temperature difference between the supply air and the return air, the speed of the compressor can be varied, and definitely reasonable amount of energy saving is possible. So here there will be two compressor in this system. One will be fixed compressor that will work in a normal designed cooling capacity. The other one will modulate. And there are two condenser fan, as I briefed earlier. To remove the heat from the condenser, there are two axial fan which take through the ambient air through the condenser coil and reject the heat exhaust basically. And there is a supply fan. There is a double shaft motor with the two centrifugal forward curved blowers, which will suck the air from the conditioned area, that is the coach, and pass through the evaporator coil. And again, cold air will be passed through the duct and to the coach. So this is how the system is going to function. Yeah, this is the overall arrangement of the components in the air conditioning system. As I briefed earlier, there are two compressors. This is vertical compressor and the other one is horizontal compressor. And there are 8 mountings. These are all most important, like these while during installation, while installing, there will be we are supplying anti-vibration mounting pads with the 10 mm plates that will be installed first on the coach, and the unit will be mounted on the anti-vibration pad. Since there will be a certain amount of vibration also due to compressor and other fans, so to avoid this transfer of any vibration on the body, as well as transferring the vibration from the body from the coach to the air conditioning system, the vibration pads are given so that there won't be any vibration transfer either from the unit or from the coach. And there is two axial condenser fans, which, as briefed, the air will be intake from this area and exhausted here for condensing application. And there are drain pipes. Two drain pipes are available at the back side of the unit, rear of the unit, which is routed from the evaporator dip tray, where whenever there is a temperature difference, there will be a condensation happens. The water collected from the dip tray, it is taken over through this pipe and it is connected through external drain pipe, and there is a provision available on the coach where the drain will be dropped over there. Yeah, so that there won't be any spilling over the coach. And condenser coil, as I believe, this is a fin and tube condenser coil. We'll cover in the last or few last slides about how to maintain the condenser coil to have a good efficiency. There are two accumulators for each compressor one. Basically, accumulator to avoid any liquid flooding to the system. Say for example, in fixed speed compressor, and say for example there will be ambient temperature is very low, so the compressor fixed speed compressor running, and the liquid, to avoid any liquid flooding, the accumulator is designed in such a way the refrigerant which comes from the evaporator, which is goes to the bottom, and there is a tube which is from the top. Only vapor will go into the compressor system. Since the compressor is designed only to compress vapor, so that is why there should not be any liquid flooding should happen inside the compressor. So this is very important. So even proper maintenance will avoid any liquid flooding into the system. If there is a no proper heat exchanger, filter cleaning and all, so there won't be any heat exchanged, so that the refrigerant which comes from the condenser and to the evaporator, the heat, once the heat removed, there will be evaporation takes place. Then the return gas will go to a certain designed temperature, system design temperature, and it will allow the vapor enter into the compressor. So there are point number 7 is fresh air dampers. Why fresh air dampers are required? Since there are around 78 passengers inside the coach, to keep the oxygen level and to dilute the CO2, carbon dioxide level, there are two fresh air dampers are provided. These are all the air volume and air quantity is calculated as per the international standards. That is, one unit will produce around 700 cmh approx, so that the fresh air will be fed into the system continuously. And there are dampers, we'll cover more in detail. There are more in detail explained in the coming slides about each components. Like, what is the purpose of fresh air dampers? There are actuators available in this system. So what is the function and what is the benefit, and safety perspective as well as functional benefits we'll cover in the coming slides. There are return air filters. This return air filter, which will, the dust particles will be filtered over here and pass on to the evaporator coil to bring down the temperature, and then blows to the coach to supply air duct. An evaporator coil briefed earlier, and a blower fan. Basically, there are two blower fans. You can see there are two blower fans. These are all the two blower fans. At the middle, there is a compressor, motor, double shaft motor, which is rotating both the blower fans to give the supply air to the coach. And OHP. Hello. Point number 12 is OHP, overheat protector. This is most important here in the passenger coach as well as in the system. There are heaters, electric resistance heaters are there. There are 3 levels of protections in the system only for the heaters. One is the first level, that is 65 degrees Celsius, and second is 85 degrees Celsius. And there is a fusible bulb that will blow off and switch off the system if the temperature reaches 130 degrees Celsius. And inside the system itself, from the blower, there is a small supply air duct arrangement. The air will comes to this area and then pass into the duct. As briefed earlier, there are one VFD, point number 14. This is VFD, variable frequency drive. I can say triple VF actually, variable voltage and variable frequency. And in this system, there is a very important component has been added, that is an inverter, emergency inverter. In case of the input 415 volt failure, the emergency inverter will function. So there is a return air damper also available here, and we will cover more in detail in the coming slides. As briefed, there are 2 fresh air filters. This is one fresh air filter, and there is one more fresh air filter to filter the air from the particles. I'm moving to the next slide, sir. This is basically the overall dimension of the unit, having some more clarity there are 8 anti-vibration pads, condensation drains, and other than that, there are few drains in the condenser area. Since the condenser area, it is exposed to the atmosphere, whatever water comes here, it will drain over there. But again, it is a normal water outside. The water temperature will be normal to the ambient, whatever comes. So there won't be any problem. And there are 2 fresh air openings. From there are air damper arrangements are there. From here, the fresh air will be intake into the coach. So coming to the refrigeration system, as I briefed, so this is the actual image of the air conditioning system, whereas this is how the compressor looks: vertical compressor, horizontal compressor, and 2 condenser coils, heat exchangers, and evaporator coil, accumulators, and line components like filter dryer, side glass, and pressure switch and service valve. Yeah, so going into detail about component level, basically we would like to make awareness about to the team who handles the machine, like what are all the components inside and what is the function, so that it will be easy to have a better maintenance. So this is a variable voltage and variable frequency hermetically sealed compressor. One is the horizontal and the other one is a vertical compressor. The horizontal compressor, as briefed earlier, I have given the graph here, comparison of variable capacity air conditioner and traditional ones. This is the comparison. There is a modulating capacity as required to save energy. So there should be a doubt. I hope there will be a doubt how it is going to save energy. Say for example, the compressor, the maximum designed condition power consumption, say 5 kilowatt, when there is a cooling requirement is less. So this compressor is operated using the PID control, basically the return air and supply air delta T. And the compressor will be run in variable frequency. Normally it will be running at 50 hertz, and whenever the cooling load is less, so that can be run automatically. It will run in lesser frequency. So in that so that over period of time, say for example in a day, even for 1 hour or 2 hour, this is only example I'm saying, practically definitely it will give more energy saving. So that way the power consumption will be reduced by reducing the input power. And one more advantage in variable frequency compressor, we can avoid the on off. While on off, any compressor which is going during on stage, the initial starting current will be very high. So in this case, the initial starting current will be very gradually, it will increase, since it is having running through the drive. The drive itself start from the lower frequency and gradually it will go to higher frequency. And whenever the compressor can run continuously without on and off when the temperature reaches. So when there is no cooling, we can run at a very low frequency, so that the other compressor will be switched off. So this will definitely help in railway. The starting current will be very, very minimal. Here actually I have not.
Just the base load is taken care of by the fixed compressor or by this variable compressor. When the variable compressor comes into picture, initially the fixed compressor is taking the load, or variable compressor
Initially,
right from the start.
no, from the start the variable compressor will be working. When there is a capacity or the heat load is more, the temperature difference is more than 3 degrees, that time the fixed compressor will be started working until the temperature reaches to the desired requirement.
Okay, thank you.
Yes. Yeah, here actually I'm not going to cover more in detail about the basic refrigeration components. Here I'm going to cover about the components which newly added in the HVAC system, in railway HVAC system for Indian Railway, this project. One is the discharge check valve, which is fixed in the discharge line of the horizontal scroll compressor. And second one is air differential pressure switch. This is fixed to check is there any pressure drop across the filter. So if there is an indication, then we have to do the maintenance. I'll be covering more in detail in the coming slides. And a safety point of view, there is a fresh air smoke detector. If there is a external smoke, this will start working. This is the smoke detector. We might have seen in normal supermarket or any malls, and this is actually rail proven smoke detector what we are using in this project. And there is a CO2 sensor, carbon dioxide levels. If it is goes extreme, there are few logics also given. This is how it looks, the return air damper actuator. This is a 24 volt DC return air damper actuator, and there is a fresh air damper actuator. VF drive is being introduced newly in this project, and emergency inverter and microprocessor controller. This is how the microprocessor integrated with the HVAC unit. Like microprocessor will have analog, digital inputs and outputs, and there are LED indicators, and there is an electrical control panel which is fixed in MEDA switchboard panel. From there, the wire harnessing will be done to connect with the RMPU, and the microprocessor also fixed inside the electric switch panel. And this controller is having integrated to all the analog inputs, that is return air, supply air and fresh air sensors and humidity sensors. Other than this, there are few other pressure transducers also there to monitor the system pressure and operate the fans accordingly, as well as give the fault signal in case of any abnormality. Yeah, so far we discussed about the components. What are all the components? What are all the new components added in this project? So now we are going to enter into the function of the systems. What are all the modes available in the systems? So we will go in detail. So any doubts, please feel free to ask. Basically, there is a cooling mode. How it is going to work? In cooling mode, basically there is a set temperature. To meet the set temperature, the microprocessor controller will allow the compressors to work until the set temperature is arrived, so that inside the comfort temperature of 25 degree is maintained. So basically what is happening in cooling mode? In cooling mode, there is a heat removal. Okay, when we go into thermal engineering, there are a sensible heat as well as latent heat. Sensible heat will remove only the heat without any vapor, whereas the latent is called the heat which is to remove the water content from the air. And as told, this unit is around 28 kilowatt design condition, and the unit will function for 15 volt, 50 hertz and 110 volt DC. Whereas we have inbuilt converter to give a 24 volt DC output to function the switch gears and all. Basically, if the temperature of return air temperature and the set temperature, that is the return air temperature minus set temperature, is negative, only the blower fan will work. Basically, I'm going through the function of the system, how it works. And similarly here, if the set temperature is greater than or equal to 1 or 2 degrees Celsius, condenser fan and compressor will work till it reaches the set temperature. And if the temperature is more than 2 degrees, both compressor and condenser fan will run till the temperature reach the set temperature. Here, how the BBF compressor is working. The set temperature will be maintained within plus or minus 1 to 2 degrees Celsius with BBF compressor by varying its duty cycle using PID control, that is a proportional integral derivative controls. That is control loop feed mechanism to the control temperature by varying the frequency of the compressor from 40 to 50 Hz. Even it may go less than 40 also if required, that's not an issue. So far we discussed about cooling mode, and there is a heating mode. Why heating is required? Suppose if that in North India the temperature goes even 4 degree or 5 degree also, that time the coach temperature may goes less than 17 degree. So whenever the temperature goes 18 and below, the compressor will switch off and the heaters will start working to maintain the temperature from 17 to 21 degrees Celsius. So this is again the function of the heater. If the set temperature minus return air temperature less than or equal to 1, heater will be on for 5 seconds and off for 55 seconds. If the difference of set temperature and return temperature, that is greater than or equal to 1 to 3 degrees Celsius, heater will on and for 30 seconds and off for 30 seconds. So based on if the temperature difference is more than 3 degree, the heater will on for 55 seconds and on for 5 seconds. So this is how the logic is defined.
We are not using the reverse cycle here.
Now in this system, we are giving the electric heating system.
In future also, are you having some idea that you will be giving reverse cycle heating because it is more efficient than the heaters?
Yeah, both are having, yes, definitely on safety point of view, this electric heater, the reverse cycle heating system having advantage, but it is having its own drawbacks. But still, actually, we are ready. We are already developing the reverse cycle system. So that will also very soon will come out with the reverse cycle system.
Fine.
That is for normal LHV RMPU we are developing. So the technology can be implemented if railway required for any system.
Fine.
Yes, sir.
Thank you.
Yes, sir. Yeah. Basically, what is happening in cooling mode, that is a dehumidification mode. Dehumidification basically to remove the moisture, vapors in the air to maintain less than 60% RH to give the human comfort. The relative humidity of the air is more than 60%, then the temperature is below the cooling set point. During this process, VFD compressor and heater will on. There is a dehumidification process where one compressor and simultaneously heaters also will on to have the post heating. Say for example, even in coastal areas, the temperature outside will be less, but the humidity will be very high. So if without having the heater, we running both the compressor continuously or one compressor even continuously, the dry bulb temperature may come down quickly. That is basically sensible heat. Whereas the wet bulb temperature will not come so quickly, so it will take some time. In that time, Meanwhile, the dry bulb temperature will go when a non-desired temperature. Say, for example, the grill outlet temperature may go less than 10 degree also. To avoid that, there is a system logic is implemented here, and it is well proven even in other LHB coaches also. There simultaneously one set of one heater will on, heater as well as one compressor will on, but the dehumidification also will happen. Once that RH of 60% achieved, the heaters will off, and compressor also will run for a few minutes and then switch off. So that is how the function of the dehumidification mode here given. So if the relative humidity return air is more than 60%, the cooling set point, below the cooling set point, during this process, VFD compressor heater shall on, while another compressor and one condenser fan will off position. The heater will switch it off after 3 minutes and will remain off for further 5 minutes. And after 5 minutes, the relative humidity shall again be monitored, checked by the hygrostat, that if it is more than 60, again the same cycle will repeat until the RH up 60%. It shall be ensured that the return air temperature should not fall below cooling set point. In normal heating mode, if the relative humidity is more than 60%, the return air temperature falls below heating set point. One compressor and heater shall on. So this is basically the logic of the dehumidification mode. So far we discussed about cooling, dehumidification and heating, and this is very important topic we are going to discuss. This is emergency ventilation. So what is the purpose of having emergency ventilation in the HVAC unit? Since the any rolling stock, the train is running, and in case of failure of the power for any reason, so there won't be any air circulation inside the coach, and having 78 passenger inside, the suffocation will start. So to avoid this, there is an emergency ventilation. There is a emergency inverter built inside the system, which is supplied by MEDA servo. So the input power taken from the battery, 110 volt DC, and the inverter will convert and give an output of 415 volt, and run the blower fan, that is the double shaft blower motor will run, and fan will start working. In this case, return air damper will close and fresh air will be keep feeding inside the coach, so that the passenger will not feel any discomfortness. So the amount of fresh air is fed per HVAC is approximately 645 cubic meter hour per HVAC unit. Since it is a running train, there are manual cooling mode. In case of any problem, there is an option. The operator can put the system for manual cooling mode, and then again they put into the normal mode. In case of any failure in the system, there is an option, the manual cooling mode. This is more in detail about the control logic, how the microprocessor controller is going to function. The logic of microprocessor controller is explained more in detail here. Again, the microprocessor controller is supplied by MEDA servo for this project. So again, we have done a joint testing also. So Here, this controller is automatic control based on the control system along with temperature, pressure sensor, and actuators. So all the components in the system is controlled by the microprocessor. So in case of a critical failure, the system shut down itself. It regulates the temperature. Basically, this is the master who controls the entire system. Here, the microprocessor controller it is designed for two HVAC unit, similar to the LHB coaches. One microprocessor controller is connected to two HVAC units, RMPUs, regulates to regulate temperature, humidity inside the coach by sensor, humidity temperature, humidity sensor, and other parameters like also monitor, that is the pressures, and to control the system. In case the temperature goes very high, one compressor will be switched off, or if the pressure goes down and the ambient temperature is very low, one fan will be switched off. So similarly, there are overheating protection switch, CO2 sensors, smoke detectors, all are connected with the microprocessor controller. Basically, this is the master to control the entire system. And the controller will be activate immediately once it gets 110 volt DC and these are all the functions at what mode, work on what mode, step by step it is explained. So it will go to self diagnostic mode, and then the controller will check if 415 volt available. If it is okay, then will indicate to the TCMS. If it is not okay, indicate to TCMS. If it is okay, then it will go to the next step. The controller shall monitor the outside ambient temperature, return air temperature, relative humidity. So whatever the temperatures it is programmed, the desired temperatures. If that is having a difference, then accordingly the system will function. If suppose when the system is on, and the ambient temperature and the inside temperature is low, less than 17 degree, obviously it will go for heating mode. So this master will say what mode system has to work based on the parameters, temperature, pressure. So there are emergency operation also there. Here in emergency operation, the return air will be fully closed and fresh air will be fully open. There are HP control switches, thermal overheat protection. Thermal overheat protection is inside the motor. So in case the temperature goes high for any reason, there will be the motors will be safeguarded. This is the normal and heating mode. This is the temperature matrix, how the system will work. Position set temperature selection, that is 1 to 7 at 20 degree, cooling set point, and heating is 17 degree. So this is how the logic and the system function. So few components we have covered here. What are all the safety devices inside the system? Here, first and second compressor is having a time gap of 30 and 5 seconds from the unit is switched on. And the pressure switches, which is a mechanical pressure switch, this cannot be tampered by any reason. So in case the pressure goes beyond the limit, the compressor will be switched off and there will be a signal sent to TCMS. Similarly, there is a high pressure safety switch. Again, the temperature goes less than 35 plus or minus 5 psig. There will be a signal given to the TCMS. This is a control pressure switch to switch off one fan and off based on the pressure. This pressure is directly proportional to the temperature. Sir, any break required or can we continue?
पंकज सर आपका फोन आ
Is there any break required or can I continue?
कंटिन्यू सर।
सर एक क्वेश्चन है प्लीज।
जी सर, बोलिए सर।
RFQ में आपने फ्रेश एयर स्मोक डिटेक्टर प्रोवाइड किया है। सपोज
जी
there is any smoke detection by this unit, whether it stops the fresh air intake or it just intimate to driver's cab.
Yeah, I'm coming in the next few slides, sir. Anyway, this is very important topic. I will explain here itself. In case of smoke, the fresh air dampers will close for both the units.
Okay.
Yeah, and message. Yeah,
Sir, it is assumed that the fresh air smoke detector detects the smoke outside of the compartment.
correct, sir.
Vice versa, if there is a smoke inside of the compartment, then whether fresh air intake is continued or stopped.
No, sir. Here, actually, in fact, we are supplying the complete smoke detection system in this project, and there is a inside the coach there are systems available which continuously the air samples are taken into the system, and if any smoke inside the coach, so there will be a command to the TCMS. In turn, the TCMS will give a command to on or off all the systems, all the subsystems.
That is okay. Whether it works as a exhaust also, in case of
Sorry, sir?
smoke detection. Hello.
No, the system, the air which is intake into the smoke detection assembly, that is from the external.
But I hope there will be also inside of the smoke detector, sir.
No, in the unit, in our unit, the requirement as well as the logic, there is already the inside the coach, there is a smoke detection system for the entire coach.
Correct, sir. Suppose
Yeah.
there is a inside of the fire accident and the detector detects the smoke inside the coach. It gives the communication to TCMS or driver's DDU. Whether in that situation your AC
Yes.
package unit works as a exhaust or it continues to give the fresh air.
Yeah, there is a separate logic, sir. I will explain more in detail on this topic, how it works.
Thank you, sir.
Yeah. Each motor is having a thermal overload protector, which is built in into the motor. That is 130 degrees is the temperature. If the motor temperature, that is the starter temperature, goes more than 130 degree, reaches 130 degree, the motor will switch off and there will be a false signal given to the system. There is a overheat protection, OHP. As I explained, there are 3 levels of protection in the system: 65 degree, 85 degree, and fusible is 130 degrees. In electric panel, we do supply
7
the
নম্বরে কি করে যাওয়া যায়? 7 নম্বর इसका उधर उस साइड है।
Hello. Sir, if there is no question, I would request the audience to switch off the mic. If any question is there, that time you can switch on, no problem. Thank you. So we are discussing about the overheat protections. One is the motor level and for the heaters. And in heater, there are 3 levels of protections. One is the 65 degrees Celsius, 85 degrees Celsius, as well as 130 degrees Celsius. And other than this, we do give the earth leakage protection. This is again mounted in the switchboard cabinet, which is supplied by Meda. Yeah, smoke sensor. So this is also newly introduced in Indian Railway. In LHP, it was not there, but whereas it has been introduced in these coaches, since it is a high-speed train. So in case of smoke, fresh air damper will close for both the units, and message will be given to CCMS display, and fresh air damper will open again after giving command. So in this case, what will happen? Only the fresh air will damper will open, so that there will be a dilution. CO2 level should not increase, and within reasonable within the short time, we have to take needed action from the driver car. Here, while giving the manual, definitely we will give more in detail, like how this smoke sensor to be maintained, how it has to be cleaned. And in switch gear and the switchboard cabinet, there are MPCBs, contactors, and yeah, this is a quite interesting topic. As per the current scenario, for the current scenario, we are giving the UV lamp to have a better air quality here. The UV lamps are mounted on the UV lamps are mounted on the return air path. So here the UV lamp, which is having a photocatalytic reaction arrangement in the UV lamp, the assembly, so that the return air which keep on circulating, and whereas the bacteria or the better quality of air will be improved. And again, whenever the blower is running, this UV lamp will work. When the blower is not working, the UV lamp will switch off. That is how the logic is designed. So that even in case of maintenance, whether the blower is running, it will work. And whenever before opening the door, again the blower will off, and we can do the needed maintenance. These are all the temperature sensors. One is the room temperature sensor, that is and return air temperature sensor, and there is one more fresh air and supply air temperature sensors. So whereas in LHV coaches and all, there was only one hygrostat, whereas in this unit, each unit is having an independent hygrostat, that is the humidity sensor. This will be percentage, RH percentage will be continuously monitored, and signal provided to system controller. Accordingly, the compressor will be working. Compressor and heaters will be working. And air pressure differential switch, basically to give an alarm if there is a blockage in the filter over a period of time, so that there will be choke in the filter. Basically, this pressure difference between the filter, initially the pressure will be less across the filter. So over a period of time, the pressure difference will increase. And in this case, the pressure reaches 200 pascals, there will be a signal given to the TCMS and fault alarm given to the operator, so that needed maintenance can be done. So this will improve the reliability of the system, to use the system very effectively. If the filter is not cleaned and the needed airflow will not be there, so to monitor the pressure drop across the filter, this air pressure differential switch is used in the system. This is a basic schematic of the interface between the HVAC unit to the TCMS. In coach, there will be one RMPU control unit which is connected to TCMS through RS485 communication. The fault in the RMPU control unit, inverter, triple VF, or all communicated to the control unit and TCMS. This is how the schematic circuit for the triple VF drive. In our maintenance manual, more in details will be provided on connection details. Yeah, so far we covered about what is air conditioning, why it is required, and schematic of the air conditioning system, and components in the air conditioning system, functions of the components, and the logic, how they, in this project, how the air conditioning modification and controls function. So next, the very important point we are going to cover is maintenance of the air conditioning system. So any system, basically we have to do periodic and preventive maintenance so that the system will work very effectively, and in turn is going to reduce the downtime as well as energy consumption. Say for example, filter cleaning is looks like simple, cleaning the filter, but it gives a very good benefit to the end operator as well as the passengers. So that's how, like based on our experience, currently we are recommending to do the filter cleaning of 2 weeks, 4 weeks, and 24 weeks. Since our India environmental condition or pollution condition is too high, and the train is traveling at high speed from one location to other location, the frequencies is currently defined 2, 4, and 24, or replace at 18 and 36 months, or 6 lakhs to 12 lakhs kilometers respectively, whichever is earlier. And it complies for even fresh air filter also. So even though there is a periodic maintenance, prior to this, if there is a blockage for any reason in the filter, as briefed earlier, there are pressure differential switch, so that it will give an indication to do maintenance. That is basically cleaning. To have a proper heat exchange, one is the filter cleaning is very essential, and next is evaporator coils, where the cooling is generated. So cleaning of evaporator
ওই
coil,
গাড়ি রিং লাগাতে চলে গেছে
cleaning of evaporator coil from opposite to air direction, that is yearly once we have to do. Similarly, condenser coil, even the condenser coil, it is not in the comfort area, that is the evaporator compartment. This is in the condenser area, condensing unit area, where to have a clean coil will have a better condensation and designed power consumption and better cooling. So smoke detector, clean the smoke detector monthly if the fault raised, and it has to be checked and attended immediately without any negligence. So there are a few guidelines given for the RDSO, but that is for the filters and all. But for smoke detector and all, based on the manufacturer's recommendation, we also going to give in the manual. So that I would request to the end customers to strictly follow, so that we can have a safe and reliable system. So I would like to cover just one slide about the reliability of the system. So among the demands are the reliability, energy efficiency, indoor air quality, and occupant comfort and control plays a vital role. Since these are all very important to us, the reliability of the system is most important. Yeah, in design level, definitely yes. We have done the failure mode, effective and critical analysis.
থেকে নিয়ে এলেন এখান থেকে কোথা কোথা থেকে নিয়ে এলেন এসছে
We have a reliable system, like we can reducing risk of failure, improving air quality and thermal comfort, handling an increased load, improving energy efficiency, and yeah, these are all the definitely benefits to have a reliable system. So from the design point of view as well as the maintenance point of view. Yeah, so far we have discussed on saloon HVAC unit, from basic air conditioning till the reliability, including maintenance and control functions. So we can move on to the cab air conditioners. This is the driver cabin air conditioner. This is a capacity of 7 kilowatt and 2 TR. The unit dimension is 1.1, 1 and 0.5 meters. And as well as the saloon HVAC structure, and this both are stainless steel SS304, and air volume 1000 cmh per unit. And this is again 4070 refrigerant is being used. Weight of the unit is 150 kg. So this is a very small system, and this is having only fixed speed compressor and controller. So far we have covered about both the HVACs, which we are supplying in this prestigious project Train 18. And one more request, since all the end users and senior officers and the operators who are going to run this train, I would request we will not exhaust any refrigerant in the environment. So we will try to maximum possible reuse or recycle. There are systems available. So yes, definitely we can support to give these systems. That's not a problem. Since any refrigerant we are exhausting in the air, which is going to harm the environment, and in case of the system, refrigerants are good, no need to exhaust in the air. Say for example, we need to change only the filter dry air, we can recover the refrigerants. So say for example, any workshop, if 1 unit per month also, if they recycle the gas, that's around nearly 7 to 8 kg. Like Indian Railway is a big ocean. So in many locations per year, even per month, 10 units we leave the refrigerant outside, it is going to harm the environment. In turn, it is definitely going to harm us. So we will try not to leave this refrigerant in the environment. Try to recycle or recover the refrigerants. Thank you all, sir, for the kind attention. And any queries, we have another 30 minutes. If any questions, please feel free to ask.
Sir, I have a question.
Yes, sir.
The entire course discussed here,
Yeah.
where is the मतलब CNW point of view से इसका क्या महत्व है? मतलब ये जो डिस्कस किया गया है यहाँ पर, ये सिर्फ मतलब पूरा ट्रेन 18 के बारे में है कि CNW ये पूरा मतलब देखना होगा, मतलब ये पूछना चाहता हूँ.
Yeah, this training program is focusedly only especially for train 18, but wherever applicable, HVAC even used in other coaches also. So wherever, in fact,
Okay.
we are approved source for Indian Railway, almost near about 2 decades. So
Yes.
wherever required, yes, definitely we can support, or any improvements required or any technical assistance required and related to HVAC, please feel free to contact us. At the end of the slide, our contact details are available.
Okay, sir. Thank you. Thank you.
Yes, sir. Thank you, sir.
Excuse me, sir.
Yes, sir.
Sir, is there both compressor are VVFD or a single compressor in a unit?
Yeah, here actually only one compressor is triple VF, variable voltage and variable frequency drive. The other compressor is fixed.
Okay. And sir, other question is that,
Yes,
speak,
sir.
sir. Please speak.
Yeah, please carry on, sir. Tell me.
Other question is that what is the reason behind the one horizontal and one vertical compressor?
No, actually, the compressor what we are using globally, they don't have the variable frequency compressor at this moment. They are under development, and very soon they will come up with vertical variable speed compressor.
Okay.
Yeah, in future we will be using. That is the reason we have to go for. I have forgot to mention one major advantage in this compressor, which is having a additional oil circulation pump.
Okay.
So that is how slightly higher capacity than the vertical compressor, and there will be a better oil management inside the system. Since the scroll compressor is so sensitive, which is there is a fixed scroll and the horizontal scroll. So if better oil management will give better performance of the system. That is how it is having a very slightly higher capacity. Yeah, the reason answer for your question, currently there is no variable frequency drive for rolling stock application. Yes, for domestic and commercial, it is very much available, being used in many industry. So, yes.
One more little question I have. That
Yes.
is the same compressor used in the inverter ACs in domestic purposes?
Sorry, sir, come again, please.
Can we say it inverter AC?
Yes, sir.
Okay, sir. Thank you. Thank you very much.
No, sorry. What is your question, sir?
My question is that in the domestic purposes, there is a use of AC called inverter AC. Now technology is used PVFDs.
Correct.
Is the same technology?
Yeah, logic will be same. See, logic will be same. There is no doubt. Based on the temperature difference or any logic they might be using for domestic application, but domestic application they are using rotary compressors.
Okay, sir.
Yeah, this is a hermetically sealed scroll compressor. Rotary compressor, the mechanism is different from the scroll compressor.
Okay, sir. Thank you. Thank you.
Yes, sir. Yeah. So since like all the key persons from the operations available here, some of them will be definitely maintaining the existing RMPOs. I would like to have some feedback, like how much of refrigerant is being put in the atmosphere, sir? I mean to say, like for during repair, like anybody, say for example, having 10 coaches, so how much of the refrigerant is being exhausted? Any other questions, please feel free to ask, sir. We have another 15-20 minutes time.
हेलो सर।
Yes, sir.
हेलो।
Yes, sir.
बोल रहे कि अगर पूरा पावर फेल होता है, गाड़ी आधा घंटा या ज्यादा खड़ी है
जी।
तो तब कुछ सफोकेशन होगा, इसके लिए कुछ सिस्टम है नॉर्मल विदाउट एनी पावर फॉर वेंटिलेशन पर्पस?
नहीं, यहाँ पे सपोज 415 वोल्ट फेल हो गया, तब तक बैटरी में चार्ज है, तब तक वो हमारा इन्वर्टर का थ्रू ब्लोअर चलेगा, शेयर फीड करते रहेगा।
ओके
जी। Sir, in any area, if I have rushed up, please feel free to raise any doubts or questions. किसी को कोई डाउट है, लाइक मैंने रश थ्रू कर दिया तो आप पूछ सकते हैं सर, प्लीज।